Carbon dioxide emissions are a major driver of climate change, and burning fossil fuels is speeding up this process. To take our foot off the accelerator, we need to switch to carbon-neutral fuels like biodiesel. Although biodiesel is great for powering our vehicles, it produces lots of byproducts. One of these products is a simple molecule called glycerol. It's not particularly dangerous by itself, but the push towards renewable energy sources means that we produce way more than we currently need. So a lot of it goes to waste. There are lots of chemical processes that can be used to convert glycerol into useful products, but they are costly and energy intensive. At Imperial, SyCoLim researchers are on a mission to recycle glycerol and reclaim it from landfill, using their secret weapon, yeast. The yeast of choice is called Urea lipolytica. You might not have heard about it, but if you take a closer look at some meats and cheeses, you will definitely be able to see it living happily on the surface. Although microscopic, don't be fooled by their size. Urea can be grown in large volumes and can be modified to recycle waste glycerol into valuable products by reprogramming their DNA. DNA is the manual that all living things use to grow and survive. It has segments called genes that provide instructions for certain characteristics, like hair and eye colour in humans. In yeast, we can add new pages to the manual, using molecular scissors to cut and paste genes, providing instructions for traits that could not be found before. Using the new directions, Urea can build molecular pathways to produce bioplastics, nutritional supplements, and fragrances. Using glycerol as a fuel, Urea can act as a vehicle for recycling waste into valuable compounds, like limonene, a citrusy oil used in pharmaceuticals and cosmetics. To do this, we need to add a gene called limonene synthase, which drives the cell to convert glycerol to limonene. Alternatively, we can change Urea's destination by adding genes that allow them to navigate down different paths. For example, adding PHA synthase into Urea allows them to produce bioplastics. Travelling down a different route, we can insert the CRT family of genes to produce beta-carotene, an important molecule for maintaining eyesight. In an effort to reduce our carbon footprint, Europe is aiming for carbon neutrality by 2050. Renewable energy sources like biodiesel will be a major driver during this transition, accelerating the production of waste glycerol. Using SyCoLim to upcycle waste and convert it into medicines, bioplastics and foods, we can shift carbon emissions into neutral. It might not be a quick fix, but Urea can act as a small vehicle of big change towards a sustainable future.